Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Mickey.
And in studio with us we have Gavin. And Gavin, if somebody needed to contact us, what would they need to do?
For math, homework, help, call 636-4357. Everywhere else is 1-866-636-6284. Their email is dothemath@kern.org. They're online at dothemathonline.net. And for social media platforms is Facebook, Instagram, Twitter, and YouTube.
All right, nicely done. So Gavin, let everybody know where you go to school and what grade you're in.
I am a downtown elementary student, and I'm in 6th grade.
And how is 6th grade going at downtown?
In my opinion, it's probably in a really good year. It's a pretty amazing experience to be with, and lots of friends, new friends that joined this year, and I feel like it's a really great year to start. Probably a new chapter in life.
There you go. Good. Well, that's a great way to look at things. Now, you have been a guest on the show before.
Yes.
So, you know how Do the Math works.
Yes.
And when you were on Do the Math in the past, I told you that you needed to be an ambassador for Do the Math and let other people know about it. Mm-hmm. Have you done that?
How do you...
Have you told anybody else about Do the Math?
My class. I mostly told my class.
See, that's exactly what I wanted you to do.
Well
Just
done,
tell some
absolutely.
other people about Do the Math, and you told your class about it. So good, that's exactly what we wanted you to do. So in class right now, what math are you working on?
Algebra and during the distributive property.
Okay, so you're working on that in 6th grade right now.
Yes.
All right, so we're going to work a little bit on that today, but before we get to that, we're going to first of all take a look at today's Math in the News. All right, well, today's Math in the News has to do with something that happened last week and will be happening coming up this weekend, the NFL playoffs. So last week, did you get a chance to see any of the games?
I saw a few of the Rams games, as I am a Rams fan myself.
There you go. All right, so last week there were 4 games, and all 4 games came down to the last possession of the game, and it was all last-second victories for all of those teams, and 3 of the 4 were visiting teams, which is quite an accomplishment, especially when you get that deep into the playoffs. So we're moving on to the next round. So now there are 4 teams left altogether. All right, mm-hmm. And we can see right here how they've come to be. All right, so here's your LA Rams.
Yeah.
All right, so they move on because they beat the Buccaneers
With a 3-point goal. That was pretty intense for me and my family.
That was one of those close ones. That was, for fans of Rams and Niners, that was an intense game.
It was a nail biter of a weekend anywhere you went. Even if we happened to be at a Condors game and everyone around us was watching one of the football games on their phone.
Yeah.
So you're watching one sport, but you're really looking for another.
And they were exciting. So here's the Niners, and I take it you're not much of a Niners fan if you're a Rams fan.
Well, obviously, my family is definitely not a Niners fan. We always call them the 49ers, but I didn't
That'll work. That'll work. We'll leave the name calling it that for now, young man. We'll leave the name calling it that. So the 49ers, I'm all right with that. Seeing as how none of these teams are my team, so we'll just leave it at that. On the other side, young man, Kansas City and Cincinnati, do you have any interest in which of those teams moves on to the Super Bowl?
Well,
Or does it matter?
in my opinion, probably the Kansas City. Like, they used to be one of the few second best teams besides the Patriots, and until Tom Brady moved to the Buccaneers, which put an end to their reign of terror on the Rams. So
Reign of terror. There we go. All right.
in my
So you would like to see Kansas City move on, or you think they're going to move on?
well, in my opinion, they probably will move on.
Okay. So you think it's going to be Kansas City and LA?
Probably if the Rams beat the 49ers.
Well, they're gonna have to do that.
If they do, in my opinion.
All right. Well, let's move on because this is just the tip of the iceberg here, young man.
I can agree.
So are you familiar with Bitcoin and other forms of cryptocurrency?
On YouTube, some people have mentioned it, yes.
Okay. So cryptocurrency is a big thing right now, okay? And Bitcoin is one of those types of cryptocurrency, all right? And the reason I bring this up is because there's a lot going on with it in the stock market right now. And cryptocurrency is going way up and it is going way down at the same time, especially right now.
So,
Your guy, Odell Beckham Jr., he came over to you from the Cleveland Browns. Okay? So here, let's take a look. On November 12th, Odell signed a deal with the Rams worth $750,000. That's not even for the whole year, because he came over during the part of the year. He announced he would take that in Bitcoin. All right, $750,000 worth of Bitcoin. At the time, Bitcoin was worth about $64,000, $65,000
that's expensive.
For one coin.
for one coin. Now it's worth $35,000. Okay. Today the deal is worth $412,000 instead of $750,000. Okay, because Bitcoin went down, so his
The
money
value of his contract. So he
went
was
down.
paid $750,000 worth of Bitcoin. But because Bitcoin is now less valuable, even though he's working for that $750,000 contract, it's valued less because what he's being paid in can fluctuate. Does that make sense?
Yeah, that kind of makes sense. Yeah.
Okay.
And California, let us not forget the grand state of California. Let's not forget New York, because those two states together probably support the rest of the other states. But we'll leave that to another time. He's going to be taxed 50.3% on that $750,000.
That's half.
Federal and California state tax together is going to make 50% that he's going to be paying. So that means Odell has made $35,000 from the Rams this year at this point. Now, Bitcoin could go back up and he makes a little more, but
or it
at
could
the
continue
time,
to go down and be worth even less.
this was on Monday when I did this. Okay? So we just wanted to tie a little bit of the Rams being in the playoffs. Know you're a Ram fan. You were going to be on. Crypto is in the news right now. Bitcoin is one of those things that they watch, just like the NASDAQ. Bitcoin, crypto, that is its own thing. Okay? And that's how it all ties together with today's Math in the News.
Now I'm curious, as someone who is grown up and cryptocurrency is normal, we could say, to someone your age, do you think people like Odell Beckham Jr., should they ask for payment in Bitcoin if the value can go up or down? What would you do? What do you think?
Well, probably in my opinion, it can see how I'm not I'm mostly like how, sorry, like I like saving money, but
Right. So, and he may not be that familiar with it. And the thing is, like, it's not like the Rams said, here's Bitcoin. So he took his $750 and purchased Bitcoin with it.
Same concept. Instead of them
Right.
giving the Bitcoin, he went
just
out and purchased
had to do it
it
himself. But
so his
yeah.
money is still fluctuating. Do you think
Right.
people should do that in the future, Gavin? Or stick with just cash?
I bet probably just do the first option.
Get the Bitcoin?
Yeah, get the Bitcoin.
Right,
right,
right, because
there
if
you go.
it doubles, you've got
Make more money, there we go.
almost close to $2 million now for not doing anything other than sitting on it. All right. Anyway, you said you were working with the distributive property.
Yes.
All right. Head over to the board. You and Mick are going to work on this problem. And you explain to Mickey how you think you should go about this problem. And if you're a little stuck, Mick will help you out.
Okay.
All right. So first we're going to go 9.
Go ahead and grab a pen. You're going to be writing it up there. Go
So
for it.
kind of go up towards the top and to the left. 9. open parentheses, so start a parentheses, open up a parentheses. You know what I mean by that?
So when he says that, it means
Mick will help you out there.
like we open it up and now we can write
yeah.
inside of it.
All right, so now -3 W plus 1 close parentheses minus 6 open parentheses -3W plus 4 close parentheses. Simplify that, please.
Simplify.
So that means use the distributive property and then simplify from there.
So,
Think of our order of operations. What comes first?
you distribute the 9 to 3 and the 1.
Okay, so if we do that, what would it become?
It would, like with -3, cannot be multiplied as
Yep.
a concern.
Yeah, so so the rule is, so for example, let's just take a look at this -3W, okay? When these are touching like this coefficient, which is the number, or it's really the number that's being multiplied by a variable, okay? Whenever they're touching like this, it means multiplication. It saves us space instead of having to make a dot or a multiplication symbol. Does that make sense?
Yeah, that makes sense.
Okay, so now the same is true when I'm dealing with a number such as 9 at the front. Is the 9 separated from the parentheses or is it touching it?
I bet.
Like, is there a plus, a minus, a multiplication, or division?
No, so it has to be connecting.
Exactly, so when they're connected, it always stands for what?
Multiplication?
Exactly. So now you have to multiply 9 times what's the first term? What's the first part in here?
-3W.
Okay, so what do you think 9 times -3W will make as a product? If the W scares you, focus on just the -3. 9 times -3.
Like my teacher never, mostly, we haven't got this far
That's okay,
yet.
so I'm going to give you a little hint. It's a triangle here. We have a positive and 2 negatives, okay? So I want you to tell me this. What is 9 times 3? Pretend that negative sign's not there. What's 9 times 3, Gavin?
9 times 3 would be 27.
Perfect. Go ahead and put it up there. Okay. Now here's the key. This 9 is positive. It doesn't have a positive sign because I already know it is. Unless it's telling me it's negative, it always stands as a positive, okay? So over here on my triangle, I'm using a positive, but I'm multiplying it by a
Negative.
negative. So what's the only thing left?
The only thing left is 1 negative.
Which means 27 has to be
A negative.
a negative. Do you know why that's true? Because the symbol helps, but it doesn't explain why. Negatives mean opposite.
Yes.
So what is the opposite of a positive number?
Negative?
That's why it's -27.
That makes complete sense now.
Absolutely. All right, there we go. So now the only thing left, well, what about that W? What was it connected to?
D3. So it would be -27W.
Perfect. Now let's take that same concept and multiply 9 by the next term.
Well, since 1 is a simple number to multiplication, so 9 times 1 would be 9.
Perfect. Now I want you to remember, this 9 we said was positive, even though we didn't see a positive sign, right? Even though this looks like an addition sign, what does it also look like? If this is negative, what is this?
Positive.
Aha. So even though now that it's there, we can think of it like what's 9 times +1? Positive 9. So we put a plus in front of it. We think of it as addition, but really it's a positive.
Oh.
So now let's clear some space. And I want you to work out the right side. Now we've kind of worked through the left side. We've talked about some of the rules and procedures and why things are positive or negative. I want you to take these same concepts and bring it over here. Okay?
Okay, so this time, like distributive property, we can still distribute it, but
Okay.
this time the first question we have is -6 times -3.
And remember, a negative means opposite, right?
Yes.
So -6 means I want the opposite of times -3. So instead of a negative as an answer, it will be
A positive.
So what would that give us?
+6?
Remember, 6 times 3, we're still multiplying.
Okay. 6 times 3 is 18.
Now would that be a positive or a negative?
A negative.
Ooh, remember, negative times a negative. Remember, so this means I want the opposite of this.
Oh, so it would be a positive, right?
Positive, yes, absolutely. And then don't forget our variable. We don't want to leave that guy hanging.
W.
Beautiful. And what's our last part? What do we multiply next?
Negative 6 plus 4. Like we said right here, so it'd be, I bet, oh, okay,
You got it.
I'm just thinking right now, since it's the whole, the one outside the parentheses that has no negative number onto it, so I have to think. It'd probably be the same thing though, right?
So what do you think, it's going to be a positive or a negative?
A negative.
Okay, negative what?
Negative 6 times, negative 24.
Beautiful. And we recognize that as minus 24 in an algebraic expression. Now, Gavin, has your teacher talked about like terms?
Like terms.
Have you ever heard of that academic?
I don't think
Okay.
so.
So I'm going to give you a quick little, okay, so terms are parts of this expression. So my terms here would be like negative 27w, that's a term, 9 is a term. Think of them like puzzle pieces in your expression, okay? How many puzzle pieces do we have here? If those are 2, how many do we have in total?
3.
Close. So remember, this one was a term, 2 terms, 3 terms.
Oh, 4 terms.
4 terms. We have 4 pieces that are being put together, okay?
Let me just help circle these two.
You're the man, thank you. All right, now, we have 4 terms, but for them to be like terms, they have to have the same variable and the same exponent. Do you see anything up here that has the same variable and exponent?
Variable and exponent. Not likely, no.
Do any of these have the same variable, like the same letter that stands for something else?
Same letter. Oh, W. 18, negative 18, and sorry.
You got it.
Positive 18 and negative 27.
There we go. So they have a common, they have the same variable. And if you didn't know, there's always a hidden number 1 up here. It's W to the first power. Okay, it's always there. It's invisible, but no one tells you about it, but it's really there.
No one tells me about it.
But now you have to come to do the math to find the good stuff. So here we are now. So if I combine a negative 27 and a positive 18, so you owe someone $27 and you pay them 18, are you still going to owe them some money?
Yes.
How much money will you still owe them?
So if you give out 18, let's say like minus, so 27 minus 18.
Okay.
So 718, you put that right there. 17. 17 minus 8 is 9, to be exact.
Beautiful.
And
1 minus 1 is 0, huh?
yeah. And 1 minus 1 is obviously 0.
Okay. So then if you owe someone $27 and you pay them back 18, how much money do you still owe them?
You still owe them 9.
So down here, we would write negative 9w. Because we had negative 27 w's and we combined it with 18 positive w's, we still have negative 9 w's. Does that make sense, Gavin?
That makes sense.
Okay. Now what about this 9 and this negative 24? Can I combine them?
Yeah, I think you can combine them, since the 9 is the same thing from here, and the 24 we got from the negative 6 and the positive 4.
Right. Do they have the same variable? Do they even have a variable?
9 doesn't, but 24 does.
24 has a letter attached to it, a variable?
Oh, sorry, no.
No, it doesn't. So that's okay. That means they're still like terms because they're the same. They're just a number, just an integer. So if you have a positive 9 and a negative 24, if you combine them, what will we have left?
So, like we got here, so positive, negative would be leave 1.
Be careful though. We're only adding or subtracting them. So it's like owing someone $24 and paying them 9. Are you still going to owe some money?
Yes.
How would we figure out how much?
By 24 minus 9. 4 minus 9 is obviously...
Can we do that?
Sorry. 4 minus 9, you put the 2 here, it's 1. The 4 will go, it would be transformed into 14. 14 minus 9 is 3.
Ooh, double check.
Oh, wait, double check?
9 and 3 is 12. You're close though.
Sorry, I had a thought.
You got it.
So, yeah, no. Trying to think right
10,
now.
11, 12, 13, 14.
Wait,
I think it rhymes with hive.
wait. 11, 10, 9, 8, 7, 6, 5, 4, 3. What I thought was 3.
It's going to be 5.
It's 5?
Yep, 9 plus 5. If you take 1 off of that, gets you to 10. The 4 left over gets you to 14. So 9 plus 5. So what do we have left from 14 minus 9?
14 minus 9 is 5.
Perfect.
It just seems a little bit confusing in my head how
That's
that
okay.
works.
That's all right. So now you said before, if I owed $24 and I pay 9, do I still owe money?
Yes.
Yes, but don't forget we have a 0 down here.
Oh, yeah.
So
I was
1
gonna
minus
say, so you gotta
nothing.
bring that 1 down.
There we go. So how much money do we still owe?
$15.
So how would I show that I owe someone $15? Would that be a positive 15 or a negative 15? Perfect. So now what we do is we take that negative 15, put negative 15 in here. Let's put a negative 15 right in there. Perfect. Guess what?
We're
You
done?
just used distributive property to simplify the equation. Nice job. That was it.
All right, so that expression has now been simplified. And you can't put negative 9w with the negative 15 because they don't have the same variable. One doesn't even have a variable.
Yeah.
All right? So it kind of makes sense as you went through it?
A little bit, yeah.
Good. Well, we're going to do some more in a little bit, and we'll do it right after this.
For generations in southeastern Connecticut, fishing was a way of life for many. But for years, the industry has been shrinking. The fishers who remain are older now, and many think that fewer young people want to depend on a difficult and uncertain way of life. But these 17 and 18-year-olds are working with fish every day. Not only that, they're learning a business on top of the standard curriculum and making money for their school. And the enthusiasm is through the roof.
I never expected kids to be so engaged with aquaculture. Every day I'm surprised by what they want to learn, the questions that they ask, and their real passion and engagement for this industry.
These students go to Marine Science Magnet High School in Groton, Connecticut. Every day, students get fired up as they apply science skills to manage an aquaculture operation.
The commitment I had to this school, I travel almost 45 minutes every day. But I also come in on the weekends. I do work a full-time job in addition to that, but I know that if our director of aquaculture were to call me and say, hey, we have a problem in the lab, he knows that I would drop whatever I'm doing and I would come and help him. What I'm thinking is we should get some of that corrugated pieces that we have. We'll tie it all together. We'll poke holes so we can get adequate flow on the water. Sure. What do you guys think about that? Yeah, sure.
They'll like having a little bit more room to live in there too.
One of the things that I love the most about this is that students take ownership in that lab. We're the ones that are maintaining it. We're the ones that are spending the late nights here with the teachers and testing water quality. And it really provides us that stake.
Besides ownership of the lab, students also get real-world business training, and both the students and the school reap the reward.
Kids always learn about math and they always learn about reading and writing and they go, why do I have to know how to do this? We learn about tank volumes and water flow and flow rates and size of fish. And those are all geometric problems that we have to learn on the fly. And then they start doing it and they go, oh my God, I'm doing math. Like, I never really thought that was gonna happen. Many of the fish that we grow in the aquaculture lab are food fish that we eat every day. All of the students learn every aspect of that business. How much do the fish need to grow? How much does the food cost? How long is it gonna take? And a lot of those fish will actually be harvested in a few months, sold to a local wholesaler, and then those fish will end up on somebody's dinner plate. All of the money that's made from that goes right back into the school to buy the next batch of fish, next batch of food, next batch of equipment.
There's even a partnership with the Mystic Aquarium to raise profitable aquarium fish.
Marine ornamental fish can be wildly profitable and much more so than food fish. So there's a real opportunity there and an expressed desire by the marine aquarium industry to source aquacultured fish, but there's not enough out there yet. So that's what we're working on trying to empower, to provide a sustainable source that takes a little bit of fishing pressure off of wild caught fish.
Ever since its founding, marine science has ranked in the very top schools in the state. And 99% of graduates have gone on to a 2- or 4-year university.
I see aquaculture expanding greatly in the next 20 or 30 years, meaning there's gonna be a ton of jobs available and opportunities available for students and workers of all kinds. All of my students, they may or may not want to go into aquaculture, and that's okay. But every single student that leaves the Marine Science Magnet High School is an ambassador and a steward of the ocean. And they promote that message out to their family, their friends, and everybody they meet.
There are so many things that the ocean gives us, but there's also so many things that we take from the ocean. So we have to come up with something that will supplement taking fish out of the ocean for years to come. We've spent 4 years learning about it. We know the positives, we know the negatives, but we also know the big things that aquaculture can do. So if aquaculture were to become big, I wouldn't be surprised if that was a marine science student leading that charge.
As I've said before and will many times, just fascinated with the ocean and everything that we can learn from it, and are still continuing to learn from the ocean. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. This is our 20th season of Do the Math. That's almost as old as you.
You know, I think you started here when I was 6 years old. So, you know, you've been doing it for a little while now. I'm losing hair just like you at this point, so it's been a while.
Keep it low, bro. All right, so anyway, one of our partners that has been here for a very long time, our friends from Science for Kern. And Science for Kern is brought to you by the Kern County Superintendent of Schools office, and with us today is Jamie. How are you today?
Doing well. How are you?
I'm excellent myself. So you've got Gavin, a 6th grade student. Right. So as soon as you're ready, kind of give us a little bit of what you're going to do, and you guys can go right to it.
All right. Well, today, Gavin, he's a 6th grader.
Yeah.
And in 6th grade, you do a lot in NGSS science. You have a lot to do with weather and climate.
Yes, we have like my teacher has mentioned weather and climate at some points, and we also did virtual Camp Keep, and we mentioned lots of stuff based on weather.
All right. So what I want to do today is I want to teach you how to make a thermometer, because thermometer is going to be an important piece for the weather, right?
I think I can agree with that, yeah.
Yeah. So what we're going to do is we're going to make a homemade thermometer, and then we're going to check out a thermometer that you would use in class, and how would you go about using this and measuring out different liquids.
Oh.
All right, so we ready to get started?
Yeah, I think we can get started.
All right. So what we did is we got ahead and got a small water bottle, and I went ahead and put a small hole in the top. So at home, kids, if you're at home, have an adult help you put a little small hole. Now what I did is I put that hole so that our straw can fit right through there.
Okay.
Now before we do that though, we want to take off the lid, and you're going to pour in some rubbing alcohol.
Rubbing alcohol, like...
Yeah. So you're going to fill in probably about 1/3 of the way.
Okay.
And it doesn't matter which percentage of rubbing alcohol that you use. They will both work.
Oh, that's
How about get a little bit more? There we go. That's good. All right. Let me put that lid back on there.
There you go.
Now, what we're going to do is, if you notice, when we look at a thermometer, do you notice any colors in there?
Red.
Red. So let's go ahead and change this water to red. So go ahead and add some food coloring. Gonna have to take that lid off there.
Oh, the lid?
Yeah, just pop it off.
Oh,
Perfect. Get some drops in there. You can start to see that it's getting nice and dark. Go ahead and put some more.
Okay.
We'll make it darker red.
Is that enough?
That's good. All right. It's got that lid back on there.
Feels so, like red's my favorite color, like.
Mine too. All right. So we got our lid back on. We have it nice and tight. All right.
There we go.
Our next step is we want to go ahead and put the straw in. But when we put the straw in, we don't want the straw to go all the way to the bottom. We want them to see some space.
Okay.
Okay. So go ahead and put that straw in there.
It's complicated to even get it in. There we go.
There you go. Go ahead and push it down. Make sure it doesn't touch the bottom. We got it?
There we go. That should be enough.
All right. So our next step is we need to make sure, because we added this hole, we don't want any air going in and out. So we can use Play-Doh or clay.
Clay.
So we're going to take a piece of clay, and what you're going to do is you're going to put it around the bottom of the straw so that it seals that really tight so it doesn't move.
Okay.
You ready?
Do I have to make it small or big?
We probably it's going to be bigger. Hold that top piece.
She's just gonna try making it cylinder.
That's good.
There you go.
Now, one of the things that I noticed when I was making my thermometer is if you look at the straw, see the straw down here?
Yeah, I can see it.
You see that the liquid, the red liquid inside the straw is higher than the actual bottle?
Oh.
That means that we have a nice tight seal.
Mm.
Okay, that was something I noticed too because I tried this too. I always want to try my experiments and I didn't see it. And then all of a sudden, it was higher.
It is higher.
Now, we need to measure something. So here's our thermometer. We're going to measure something. So what I did is I warmed up some nice hot water. Okay. I'm going to go ahead and pour it into this bowl. What I want you to do is I want you to put your thermometer inside. Now closely watch that water to see what happens. Do you notice anything?
Oh my gosh, I can see it.
You see it?
Yeah, I can see it.
So what is going on inside that straw?
The hot pressure inside of the water bottle or the homemade thermometer is that the heat, with the heat's intensity, the water's going higher by the second. It looks like we made, oh no, it's going higher. Look how high that thing's going.
Do you think it can get all the way up to the top of the straw?
Depends.
Okay.
Depends.
We can watch it for a little bit to see if it does.
it
Will
did-
it get up that high?
It's just like someone's like drinking water very slowly. It's just like, it's pretty intense how you can see it. Feels like an actual thermometer difference.
Okay. Now, what if I went ahead and added cold water to that bowl? What do you think would happen to that red straw or the liquid in the straw?
We can check.
Well, we're not going to check yet because I want to use some cold water in our next experiment.
Oh, okay.
But what do you think? I want you to predict what would happen.
It'll probably like start slowing down a little bit, probably start going down.
Okay. All right. So we can check out that prediction in a little bit. But the first thing is we're going to definitely notice, look what I see.
Look how it is. It's going higher.
Right.
Well, what happens if it gets a little bit too high?
What do you think would happen?
It'll just go out?
You think it would just fall out of the straw?
No, all water's gonna go out. Like, get out of the straw, you know? Like, that's what I think.
Well, looks like it kind of slowed down. But this water right here, do you think this water is going to get hotter or cooler as it sits out?
Hotter.
You think in the room temperature? Oh, there it goes.
Oh.
So what was your prediction? Is your prediction right?
Probably. I'm not sure.
What happened?
Oh, it stopped. It's...
No, it's leaking out on this side.
Oh. But how about we test if we take it out, what would happen?
Okay, you want to do it? Well, you know what? That's going to make a mess. So we're going to wait on that because I want to show you how to use a thermometer first.
Oh.
So we're going to put this one aside and we're going to come back to that experiment, okay?
Oh wait, it started going down.
Oh, there you go. You think that water's cooling down in there?
Yeah,
could
it
be.
is.
So we'll keep looking at that. All right, so we have right here, we have 3 cups. Okay. Now, before we get started with these 3 cups, I want you to check out this thermometer. Okay. Now, in science, if you notice, this is the one we would use. This is a thermometer we use in science class. You have 2 measurements on there. You have a Celsius and a Fahrenheit. So you see that right there? Okay. We like in science to use Celsius. Okay. And when we measure things in Celsius, everybody in the whole world knows exactly what we're talking about.
Yeah, like how like the weather is like For the weather forecast, we are
Exactly.
having like,
Perfect. So if you notice too, do you notice what it says 0 and then the next number is 10?
yeah.
So if we look at this and I have 0 and then I have my 10, and how many lines do I have between 0 and 10? Check on it.
10.
No,
No,
check on it
5.
again. So I have 1, 2, 3, 4, 5. What am I counting by?
Celsius?
We are counting by Celsius, but I can't use, so what is this number right here going to be?
4.
Why is it by 4?
Because if you mean by 10, it could it could be counting by 2s.
Right, so the first one's going to be 2, 4.
6, 8, and then 10.
Got an extra line in there. All right, so we have our measurement. All right, now what happens, because I saw you earlier when you were doing some problems, you were doing negative integers, right?
Yes.
What if I go this way? What's this temperature going to be?
-6.
Awesome, good. Now, I didn't do something that I should. I always should, in science, make sure I know my units. So I should do degrees Celsius. Okay, so I want to make sure when I'm writing it, so it would be 4 degrees Celsius. So I need to let everybody know what unit I'm using. All right, so you ready to use it?
Yeah, let's get ready.
All right, so I have 3 cups here, and let me pour water into this one.
Yeah, I was thinking like, yeah, that's empty. It was like, it feels empty.
There's a reason why.
Yeah.
All right, so what I want you to do is I want you to figure out the temperature of each one.
Okay.
Okay. Now, when you put that in there, you need to leave it in there, the thermometer in the water, and wait for it to stop moving, just like you saw in this one where it stopped moving. Look at this one.
It's just
It's still up there, right?
It's dangling.
Right, so let's go ahead and try this first one. Go ahead and put your thermometer in there, and let's turn it around sideways so that the kids at home can see the same thing. So what could you see?
It's going down. It's going down to be exact. Well, I think it is going down. I'm not sure. Oh, it is going down.
Okay. So what's the temperature so far?
So far, I need to check if I take from this side. I think it's about, it's almost like it's in between like 12 degrees Celsius, 10 degrees Celsius. It's around that point.
Okay. Now let's use this one and check the next one.
Oh,
Okay,
I'm just
let's
gonna.
turn it sideways again.
There
Let's
we
go
go.
this way. So you can come on this side.
Okay. Oops, sorry. I
You're
stepped
good.
in water.
You're good. What does it look like?
Oh no, I think it's like it's going down a little bit.
So what's the number though?
Oh, the number.
What's the temperature?
I think it's in between, so I have to say 21 degrees Celsius.
Okay. And what was this one again?
12, like I think 11 degrees.
Okay.
Oh, it's about to hit. Yeah, it's 11 degrees
All right.
Celsius.
So let's take this one and let's put it in our last cup.
That's the hot one.
Check it out. What happens?
Oh my gosh, it's going up like a skyrocket.
Can you tell what the temperature is yet, or is it still moving?
Yeah, it's still moving. It's
What's it at now?
it's over 50 degrees Celsius. I can tell you that.
Okay, 50 degrees Celsius. So we had, the first cup was again?
12 degrees Celsius.
This one was?
21 degrees
And
Celsius.
this one was?
Over 50 degrees Celsius.
Okay, now you know how to use a thermometer in class, right?
Yeah.
Pretty cool, huh? Now, what did you notice on the difference between this first one and this last one?
That this one was hot, this one was cold.
What did you notice on the thermometer?
The red line, which indicates how hot it is, it went skyrocketing up. Well, this one was like around the like 10 degrees Fahrenheit meter.
Okay. So you noticed on the hotter temperature, the thermometer went up. On the colder temperature, the thermometer went which direction?
Down.
Down. So Do you think if we add some cold water, what do you think is going to happen to that thermometer?
Probably going to start going down.
We'll go ahead and add that cold water and find out what happens. All of it. Yeah, go ahead and add all of it. Can you see any movement on it?
No difference, but still going higher. Wait.
What?
Oh, it's going up again.
It's going up again?
Up and down. Wait, it's going down again. Now it's going back up. Yeah, still a little bit no difference, still
Yeah.
hot.
When we added, we could have took the hot water away and we could have added cold water. So your experiment later on is I want you to try this with taking and just putting cold water in there.
I think I have a, I'm gonna do that probably when I go straight home. I'm just gonna test it out.
I would test it out, and so then you can answer your question because look what's happening again,
It's going down.
right?
Yeah, it's going down.
All right. Well, today we learned how to use a thermometer. We made a homemade thermometer, and we can definitely see there's some activity still going on in our thermometer today.
It's going down a little bit, I have to say.
Yeah, look at it go. Gavin, I want to thank you so much for coming in and learning some science with me today, and I hope you can take this back to your classroom and teach your other students how to read a thermometer.
When I have
There
the
you go.
chance, I will.
All right, that's
Nicely
awesome.
done, an ambassador for science for Kern. Now, so Jamie, if somebody wanted to know more, if an educator wanted to get some supplies for S4K, where would they need to go?
You can go to www.scienceforkern.org, get some free materials for your classroom and some great NGSS lessons.
All right, and if somebody, so let's say somebody goes, hey, you know what, I'd really like to do this. How, is there a time limit they have to hold the materials?
No, they can actually, I have schools who hold it for a whole quarter. That some have it, they can go through science within 4 weeks. So there's different amounts and we can work that out together.
All right, there you go. Nicely done. Thanks for coming in again today.
Thank
Once
you.
again, Science for Kern, a great partner of Do the Math during the last 20 years. We'll be back with more right after this.
I literally called it good. No, it's good after he got
I've always wanted to do clothing as a young age, and seeing advertisements through different companies and business logos, it's kind of inspired me to wonder how it was made in the first place.
There's a lot of things that we do in the program. We use Photoshop and Illustrator. We also do videos. You know, it's a bunch of social media stuff. So there's just a lot that you can do along with the marketing aspect. So yeah, there's just a lot to do in it.
Teaching what I know to students, I think, is kind of a undervalued representation in Kern County. And I think it's something that students are already doing on their own, but why not do it in a structured program where they can get certifications for it? Students are currently working on a competition for the Kern Economic Development Foundation. They have to come up with a portal name and a logo and then marketing efforts for it. Math is incorporated when the students are creating art boards. You know, like a letter size is 8.5 by 11, so there's that math is incorporated in that way where They have to rule of thirds, figuring out how to place stuff, dates, times. So yesterday they were working on a flyer for food sales fundraiser, so they had to put, how much items are going to cost, and then the leadership team actually has to source the items and then figure out how much is a profit versus how much has to be spent to acquire those items.
And a big thanks once again to the staff and students over at ROC and CTech. Those videos that you watch are 100% entirely produced by the students at CTech, and we certainly do appreciate their partnership once again with Do the Math as we celebrate our 20th season this year. In studio we have Gavin, a 6th grade student from Downtown Elementary. He's been on Do the Math before, is a very good ambassador for Do the Math, has told his other students and friends about Do the Math. Working with the distributive property right now in 6th grade, so we're going to do another problem to help get you a little more comfortable with it.
Okay.
All right, so head on over to the board. Here we go. So open some parentheses on the far left again.
Parentheses.
9W plus 4, 9W plus 4, close parentheses, minus, open parentheses, negative 6W, minus 9. Close parentheses. Have at it, boys.
Okay. Just thinking here
Go for it.
that since there's no hole on the left side, like I'm used to that, just using the distribute property, I just tried thinking of how I can do this, and like I said, I haven't mostly taught this by my teacher, so it's make it a little complicated for me at first.
So where do you want to start? You want to start on the left side or the right side?
Probably the left.
Okay, what do you notice on the left side?
There's a 9W plus 4.
Is there anything outside the parentheses to the left that would change or modify or have to be distributed inside the parentheses?
I'm not sure.
Well, do we see anything? Are there any
Well,
numbers here?
there's a 9.
What about out here?
Nothing.
No. What if I told you there's an invisible number there?
Really?
What number do you think would go there that wouldn't actually change anything? What's the number that if I multiply it, it doesn't do anything?
I have to say 1.
You are correct. So go ahead and put that in there. A 1. Now, if there was a 1 in front of that set of parentheses, is there another 1 somewhere else, do you think?
Right here.
Exactly.
Because like I was thinking like I see a minus, yeah, there has to be an invisible number there, but I was not expecting there.
Yeah, so there's always a 1 in front of them unless there's another number present.
Oh.
So now, do we really have to distribute the 1 to the 9W and the positive 4? Is it going to modify anything?
No.
Why not in this case?
Because as we know, 9 times 1 is just going to equal the same number.
Perfect. So then what would be 1 times 9W? Perfect. Now the next part, 1 times positive 4.
Same thing, 1 times positive 4 will just equal itself in the meantime.
Okay. So far you're telling me we have 9W plus 4, nothing has changed in the first part.
Yes.
Now what about this right side? Is there anything different over here?
I think because of the -1 and -6, we can make something with it. Like, it can turn into a positive.
Because a negative wants the opposite, right?
Yes.
So what's the opposite of a negative?
A positive.
Beautiful.
So, -1 times -6 would probably equal no negative this time, just equal regular 6.
So then what would I have to put here to show a positive 6? What would be next in my expression? Go ahead and put it up here. We're going to continue writing because it's all still connected.
Okay. Positive 6.
Oh no. You left someone behind.
Oh yeah, the W.
Okay, there we go. Good, we didn't
I was
lose.
thinking,
All right.
it's like thinking, and then there's the W.
You got it. So now the next part, you distributed -1 to -6W. What else do we distribute the -1 to?
Then -9.
Okay, what would happen after we did that?
Same thing with 6. -1 times -9 we equal just plain old 9.
Plain old 9 or positive 9?
Positive 9.
Positive 9. How would I show positive 9 in that algebraic expression to finish it off?
Right here?
Is it just a random 9, or do we need to put something in front of it? A plus. Okay, perfect. So Gavin, I'm going to go ahead and erase the stuff you did down here. Oh, that's a color filler. I don't want to use that. I'm going to change the color of everything. All right, so as I'm clearing this out, I want you to think to yourself, last time we talked about like terms. In order for them to be like terms, they had to have the same something. What did they have to have that was the same in order for them to be like terms, Gavin?
Like terms. The 9 and the W and the 6, positive 9W, 9W and positive 6W.
What makes them like terms? Why do you think those are like terms? What do they have in common that's alike?
The W's.
So the variables are the same, but what about the exponents? What exponent do they both have that we can't see?
A positive.
A positive 1.
A positive 1.
So again, the rule for like terms, a lot of people think it's just about variables, but it's the variable with the exponent. Okay? So let me quiz you on that concept real quick. Okay, so if I have 2W plus 2W to the second power, are these like terms? If a like term has to have the same variable and the same exponent, are these like terms?
I'm probably going to have to guess no.
What makes you think no?
Because, as you just said, it has to have 1 and this one's 2.
So they might have the same variable, but they do not have the same exponent.
Yes.
That's awesome. So now looking at this, you think these are still like terms?
Yes.
With W to the first power, W to the first power?
Yes.
Okay, go ahead and combine them. What would they combine to become?
So 9 plus positive 6 equals, it would equal 15W.
Aha, good catch.
But just in case, I'm probably going to add the
Just in
positive.
case, just keep the positive just to remind ourselves. It's not a bad idea.
Yeah.
Now, is there anything else I can combine that are like terms on this problem? You already combined the 9W. I'm going to cross it out. We use that. We use 6W. Is there anything else left?
The 4 and the 9?
Can we combine them? Do they have the same variable and exponent?
They both have none.
They both don't have it. So technically, they are like terms.
Yeah.
They have the same variable, no variable.
Yeah, so 4 plus 9 can be easily turned into...
Use the power.
13.
Positive or negative? Not saying you're wrong, I just want you to tell me. Positive, perfect. So what would that look like if I took positive 15W and positive 13 and needed to put them in the same expression down here as your final answer? What would that look like?
In my opinion, it would probably be positive 15W plus 13. No, positive 13.
All right, so let me ask you this. If I take away this positive, is 13 still positive?
Yeah,
Why?
because there's no negative near
And
it.
there, what is this? Is this a positive sign?
Yes.
We just call it addition, though.
Yeah.
Awesome job. So you think 15W plus 13 is our final answer?
Yes.
Let's look at Mike. Mike, how do we do?
Indeed it is. You
All
boys are 100%
right,
correct
nice
so
work.
far. All right, here we go. Clear the board.
Okay.
And Gavin, I'm going to have you write a couple of fractions up here. We're going to multiply fractions right now because this is something you said that you've done, but we're just going to make sure that you're still comfortable doing it. All right?
Okay. Just trying to finish erasing all of this.
You got it. There we go. Just the little pieces. All right,
There we go.
bring it on.
All right.
We got
So
this.
up at the top, put 5 over 6
5 over 6.
times 8 over 7. Now do me a favor and down at the bottom of the board, write it even lower down and stay over to the left. Write it again, 5 over 6 times 8 over 7. So what I'd like you to do is go through this, explain to Mickey how you would like to approach the problem, and I'm going to give you guys about 3 minutes.
3 minutes.
And if you get to the second way, great. If not, we'll just get through the first way. All right, go.
Okay, so the first thing I see, I think I can definitely multiply them. So I'm going to start with 5, 6. So 5, 6. So this is how I multiply it. And then I times it by 8 over 7. And did you just?
Nope.
I thought I did.
That's magical. I don't know. Keep it going.
So like how, if it was division, it would be like saying, like keep this the same, like change this to multiplication and then flip them.
Okay.
But since it's not that, we won't. I just want to mention that
I
out.
like it. Good idea. Good understanding.
5 times 8 is 40, and 6 times 7 is 42, if I'm correct.
You are correct.
Good. And Mick, we're going to give you a minute, maybe 90 seconds to go through the next way on how to do this.
So before we jump into that, Gavin, can I simplify 40 over 42? Because that's going to make my part make sense. Can both of those, can that numerator and denominator both be divided by the same number?
Probably?
Are they both even?
Yes, they're
Yes,
even.
which means they both can be divided by
2
Let's do that real quickly. 40 divided by 2?
is, no,
What's half of 40?
20
Beautiful. Half of 42?
is 21.
Beautiful. Okay. So we were able to solve this, but at the end we had to simplify, okay?
Yeah.
So instead, if I set this up, 5 over 6 times 8 over 7. The question is, can I simplify? Because right now, these are simpler numbers, aren't they? 5, 6, 7, and 8. Pretty small numbers, right? 40 and 42 begin to get a little more complicated. So what we can do is cross-simplify it. So looking here at 5 and 6, can these be simplified by anything? If not, you can just say no. But if you can think of something, let me know.
Probably not.
They can't. You're totally correct. So we can't simplify those. But what about 8 and 6? Can they both be simplified by the same thing?
Yes, they can.
Go ahead and circle them. What can they both be divided by?
Always, since they're even, it's definitely 2.
Okay, so I want you to think mentally in your head, no, we're not going to multiply by 2. We're going to divide by 2. We want to make them smaller. We want to make them easier to work with. So I want you to think to yourself, what is 6 divided by 2?
6 divided by 2 is 3.
Perfect. Get rid of the 6. Let's replace it with a 3. And what about the 8? 8 divided by 2?
Obviously, it's 4.
Very well done. Now, can we simplify anything else? Can we make anything else smaller and easier to work with?
I'm not sure with.
Well, you already said no to 5 and 7. Can 4 and 3 get any smaller by dividing by the same number?
4 can, but 3 can't.
So we can't do it together.
Multiply
That's
right
okay.
across there.
So go ahead and multiply across. What do we get?
Multiply across. This time, we got 5 times 4, which is 20, which is half of what our original answer was.
Yep.
And then 3 times 7 is 21.
Nicely done. And for your great effort today, you've got yourself a meal courtesy of our friends at the Broken Yolk Cafe.
Woohoo!
I like breakfast.
Yeah, there you go. Who doesn't like breakfast? All right. Hey, did you learn a little something today?
I learned some things.
Good. Did you have fun today?
I did have lots of fun.
Even better. Well, you know what? Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, California Resources Corporation, Panama Buena Vista Union School District, Bakersfield City School District, and Kern High School District, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.